Hey guys, welcome back once again. Today's topic is exponents and roots. So these are the topics which are commonly tested in competitive exams. So let's see what are the basics and the fundamentals you need to know to crack the questions related with this. Alright, so let's get started. Exponents and roots. Let's discuss first with the exponent and later we'll discuss about the roots and the fundamentals required, right? The exponent of a number says how many times to use that number in a multiplication. In general way, we represent exponent of this form. So a to the power m. So where a is called the base and the m is called the power, or sometimes we refer it as an exponent as well. And this is the reason we say, this representation we say, and doing the certain operation with this we say doing operation on exponent. So let's consider an example, 2 to the power 3. So this can be written as 2 times 2 times 2, isn't it? And it says the exponent of a number says how many times to use that number in a multiplication. When I'm using 2 to the power 3, it means I have to use 2 3 times in that multiplication. That's the meaning, right? So this is equivalent to 8. So now let's see what are the varieties of laws or the rules we need to know to solve a questions related with this. The first law or a rule what we need to know here is any number to its power 0 is always equals to 1, no matter what that number is. So it may be 100,000, 1, 2, anything. Any number to its power 0 is always equal to 1. Example, if I say 5 to the power 0, its value is gonna be 1, right? Okay, the second law here is a to the power m times a to the power n. So in this case, both the situation bases are same, a, and this term is got multiplied. Then whenever this is the situation comes, so you can also write it this in the form of a to the power m plus n. So example, when I'm writing 2 to the power 3 times 2 to the power 2, this can also be written as 2 to the power 3 plus 2, that is 2 to the power 5. So that is the we use this exponential rule. Next, a to the power m divided by a to the power n. So when there is a division with the same base, this can also be written as a to the power m minus n. So let me take one example here, 2 to the power 3 divided by 2 to the power 2. So this can be written as 2 to the power 3 minus 2. So this is equivalent to 2 to the power 1, that is just 2. All right. And the fourth rule what we may need to know here is a to the power m to its power n. So that will be written as a to the power m times n. So mn means it's m times n, it's multiplication, right? So let me take 2 to the power 3 to its power 2. This can be written as 2 to the power 3 times 2, that is 2 to the power 6. All right, so let's take next. A to the power negative n can be written as 1 over a to the power n. So if there is something with the negative, you have to take that to the, you have to reciprocate it. So that is 1 over a to the power n. This is what we can write. So let me take 2 to the power negative 3 can also be written as 1 over 2 to the power 3. And if there is any question relating with the negative power, you can directly take them down and you can apply the whatever the condition they have given to you. All right, so these are the basic rules what we need to know to solve the few questions relating with the exponents. So let's see some example. Okay, let me just let me write few more, because something I can write it as a to the power a times b to the power m, because two number are got multiplied and the common as their power. This can also be written as a to the power m times b to the power m. I can distribute in this way. This power can be given to the individual, right? The next, a by b to the power m. In the same way, I can also say a to the power m by b to the power m. So in the exams the questions may be asked in any way. It's not necessary that you have to go from this side to this side only. The question they may given in this way as well. 2 to the power 3 example. So 2 to the power 3 over 2 to the power, sorry, 3 to the power 2 3, 2 to the power 3 over 3 to the power 3. This can also be written as 2 by 3 to the power 3. So like this they may ask you in either way. All right, so let's take some example relating with this. The question one says here, which of the following is equivalent to 3 to the power m plus 3 to the power m plus 3 to the power m for all positive values of m. So now they are saying this expression is equivalent to which of the following. So then how do we do that? Now look, let me tell you, when I'm writing it as 2 plus 2 plus 2, how do you write this? 2 plus 2 plus 2, that can be written as 2 times 3. It says like 2 I am adding 3 times. That's how we relate the addition with the multiplication. 2 plus 2 plus 2, it means you are adding the number 2 3 times. That's give you the result here as 6. So same thing, if you add 2 plus 2 plus 2, this is also gives you a result as 6. Now this expression, if I write it in the way like 3 to the power m plus 3 to the power m plus 3 to the power m, so it's same, I can write it here as 3 to the power m plus 3 to the power m plus 3 to the power m. So it's same it as 3 to the power m, you are adding it 3 times, no matter how many times it is. So it's in here, so that is they have given it as 3 times, that is 3 to the power m, you are doing thrice, so that's you have to write it as 3 to the power m times 3. Now how do you convert this one in terms of an exponent? So we don't have anything which is 3 to the power m times 3, so this one can be further written as 3 to the power m times 3 to the power 1, right? It's a bracket, so it's a multiplication. If I am not writing anything on the power, means power is always 1. So now look at, now use the second identity here, a to the power m times a to the power n. So this will be written as a to the power m plus n, that is a to the power m plus 1 in this case. So which is the answer here? Answer related to this question, it's gonna be a, 3 to the power m plus 1. All right. Okay, let's take another example here. It says if 3x minus y is equals to 12, what is the value of 8 to the power x divided by 2 to the power y? So remember, you can use the exponential rules only when their bases are same. All right. So this is how. Now but here the base here is 8, but here the base is 2, then how do you do that? So 8 and 2 are not same, so you have to convert either uh, numerator in the same base or the denominator with the same base based on the type of the question they have given. Now look at, in this case 8 can be written as 2 times 2 times 2. I can also write 8 as 2 cube. All right, so now replace 8 with the 2 cube, then this expression is further become 2 cube to the power x by 2 to the power y. All right, so this now we can write it as a to the power m times 8 to its power as n. So that's, this can be written as 2 to the power 3, and its power x can be written as 2 to the power 3x over 2 to the power y. Right, now we made the bases are same in both the case. Now I can apply the identity rule. Now this can be written as 2 to the power 3x minus y, isn't it? A to the power m over a to the power n, we can write it as a to the power m minus n. In the same way, I can write as 2 to the power 3x minus y. And what they have given to us, the value of 3x minus y is equivalent to 12. So don't just try to solve this, because just they are saying this is the if, this is the condition, right? So then we can write it as 2 to the power 12 will be your answer, and that is a is the right answer to this question. All right, so this is how you just solve the questions relating with exponents. Okay, let's take another example. X to the power a square divided by x to the power b square is equals to x to the power 16, and where they are saying x is greater than 1. Now a and a plus b is 2, what is the value of a minus b? So this is a very good question. But before going to that, let me tell you a few concepts relating with this. If we have base is same, a to the power something 2 is equals to a to the power, let's take x. In the both case, if the base is same, then I can equate their power, then I can say the value of x is equals to 2. If their bases are same, I can equate their power. When I'm saying the bases are same, it means including the sign, not positive not negative. If both are negative, both should be negative. If both are positive, the bases both should be positive. One positive one negative, we can't apply that rule here. Okay, so when the bases are same, I can equate their power. In the similar way, if I'm writing here as, let's take x to the power 3 is equals to, let's take x to the power a. In this case, now look at it again, when the bases are same, I can equate their power. I can say from this one, the value of a, it's gonna be 3, right? So this case we can write. Now again, if I'm saying, let's take a to the power 5 is equals to 4 to the power 5. Now in this case, both the powers are same way. If the powers are also same, then I can equate the bases. So I can also do now a is equals to 4. So these are the two other exponential rule what we need to know apart from the listed above, right? So this is the one, this is what we need to know, and this is the second one. If the bases are same, I can equate their power, and if the powers are same, I can equate the bases. So let's see. Now this question is relating with this part. Now x to the power a square by x to the power b square is equals to x to the power 16. Now and a plus b is equals to 2 they have given. So what is the value of a minus b? Now look at here, in both the case, base is x and the powers are here a square and power here is b square. It's like a to the power m divided by a to the power n type of, right? So this can be written as x to the power a square minus b square. So that is equivalent to x to the power 16. Now look at, in both the case, the base is same, that is x. X to the power a square minus b square is equals to x to the power 16. In both the case, base is same, then I can equate their powers. So now what I can do, I can write a square minus b square is equals to 16, right? Now a square minus b square is an identity. So remember, I listed you the three identities and I said very important for the competitive exams. This is the one of those among that. So this a square minus b square can be written as a plus b times a minus b, that is equals to 16, and they have given us the value of a plus b. Now I can replace a plus b with the 2, then this becomes 2 times a minus b is equals to 16, but we are looking for the value of a minus b. So divide this expression by 2 to get the value of a minus b. So a and a just get cancelled out. 2 times 1 is 2, 2 times 8 is gonna be 16. So that gives the value of a minus b here, it's gonna be 8. So that is answer A is the right choice for this question. Alright, so this is the varieties of question what you expect. Alright, let's take the another question here. Another question, okay, before going to this question, again let me discuss some basics relating with this. Any number, let's take, if the number is a negative and its power is even, this number will turn to be a positive number. I don't know whatever that number. Example, I can say negative 2 to the power 4. So negative 2 to the power 4 is equivalent to 2 to the power 4 itself, because if the power is even, then that number becomes positive number. So 2 to the power 4, it's gonna be like, I can say here as 16 something. So but if the number here is negative and the power here is gonna be odd, then the sign of that number is gonna be negative. Okay, example, if I say negative 2 to the power 3, so 3 is an odd number, then it's gonna be 2 to the power 3, this can be negative 8. It as good as 2 to the power 3 with the negative sign, so negative 8. So what I'm trying to say here is, if the power is even, if the power of that number is even, then the number is going to be positive always, whether the base number is positive or negative. But if the power is odd and the base number is negative, then the result is going to be negative. All right, so now let's take one example relating with this. And you can't, you can't equate the negative number with positive. As I told, if you are comparing the power with power or base with base, they should have with the same sign. You can't equate the power, one number is negative, another one is positive, with like that. Okay, so now look, negative 3 to the power 4k is equals to 3 to the power 10 minus k. Then what is the value of k? Now they are saying if k is an integer such that, this is the condition. Now they are asking us what is the value of k. And I told you, if the bases are negative, I can't equate their powers. Here it's saying negative 3 to the power 4k, and here it is saying 3 to the power 10 minus k. So what should I do now? If you observe carefully, the this 3 to the power 4k, it's basically the power here is e1. 4 multiplied by any number, that k is an integer, 1 2 3 4 5 anything. So 4 multiplied by any number, its power is e1. You know that the entire result is going to be e1. So negative 3 to the power 4k can also be written as 3 to the power 4k. This is equivalent to 3 to the power 10 minus k. Now we got bases are same both the side. Here is 3 to the power 4k, 3 to the power 10, 10 minus k. That is 3 is the base here and 3 is the base here again. Now if the bases are same, I can equate their powers. Then I can write as 4k is equals to 10 minus k. All right, so simplify for value, simplify for k. So just get rid of this k from this side. So plus k here, plus k. So what happens? K and k that cancelled out. Then 4k plus k, it's going to be 5k is equals to 10. As we are looking for the value of k, so divide by 2, divide by 2, sorry, divide by 5. Divide by 5 and divide by 5. The value of k here is going to be 2. So that answer to this question, it's going to be B. B is the right answer. Alright, so these are just a simple examples which I have included. As I told you before as well, once I complete with discussing the all the theoretical part of the entire concept, what you require for the competitive exams, I will be starting of solving the questions related with the topics. Alright, so let's move to the next topic which for today, which we have mentioned, that is the roots. Let's say see some of the basic rules which is related with the roots, that is laws of roots. The first and the basic rule what I need to know about the roots here is, any number with the root, let's say root of a, this can also be written as a to the power half. So whenever I'm not representing with root with any number, it means it's, we say the square root. Always the 2 is the square, means it's a 2. We are talking about the square root, means that we have there is a 2 available here. We never mention it. All right, so a to the power square root of a can be written as a to the power 1 by 2, because it is a square root. Now if I say cube root of a can be written as a to the power 1/3, because it is the cube root. Whatever root there, it should go it like 1 by the same value of that root. And in general, if I am saying nth root of a can be written as a to the power 1 by n, right? So whenever we require, because this root we are converting into exponential form, and whenever we need, we can make use of them. All right, better let me expand this. Okay, the second rule here is, whenever there is a multiplication of two roots, root a times root b, this is the multiplication. Okay, root a times root b, I can write under the same root, that is a into b. If it is possible for me to simplify, I can simplify. If not, I can keep them as it is. Example, I can say root 2 times root 4, or this can be written as root 8. So if it is possible for me, so this can be further can be written as 2 root 2, because root 4 is a perfect square number, so I can take it as out. So this can be further written as 2 root 2. All right, Third point here is whenever root a divided by root b. So that is, if this is the same root, I can write this a by b, and this root can be put it as together. Root a by root b can be written as uh, same root with the number inside, that is a by b, the complete root with the all together, right? So example here I can say it as root 3 by root 4 can be written as square root of 3 by 4, right? So this is the way of representing the roots. Next, square root of a, and if I square this is equivalent to a. That is what we say, to get rid of a square root we have to square it. So square root of a, and if you square it, that is equivalent to just a. So example here, square root of 3 and it's a square, I can say its value is equivalent to 3. But if we have something square root of a square, this is equivalent to plus or minus a, not just a, because square root of a square is equivalent to plus or minus a. Why? Because I don't know whether a is positive or negative. So as it is getting squared, that's why I got it as a positive, and then it appeared as an number without a negative number, without negative sign. Example I can tell you, square root of 4, we can say it as plus or minus 2. Why? Because 4 can be written as square root of minus 2 square, or I can also write square root of 2 square itself. In both the case, that gives me the result as square root of 4 here also and square root of 4 here also. But I don't know whether my number here is it's getting the negative 2 square or positive 2 square. I don't know. That's why whenever you get rid of a square root, you have to write plus or minus of that number if the number is in this way. All right, so that's why we say it as in a if you want to take, then let's take x square is equals to, like we say 25, then we say, example I'm just taking it out, and this we say x is equals to square root of 25, then we say it as uh, you know that is equal to plus or minus 5. So to get rid of this square, we have to, what we have to do, we have to put a square root on both the sides. So that's, the square root and square get cancelled out, we left just with x, and the square root of 25 can be written as plus or minus 5. So this is how we write, right? Next, square root, let's take root a plus 1 divided by, let's take root a minus 1. Whenever there is a square root under the denominator, you can't use that as it is, you have to rationalize the denominator. How do we do the rationalizing? Rationalizing is basically multiply and divide by the denominator, but opposite in sign in between. So here it's a plus minus sign, so we have to do it here as root a plus 1 divided by root a plus 1. So when you multiply or divide by the same number but opposite in sign, so after doing multiplication, the root sign from the denominator will be removed. Okay, no problem. If the root is available at the numerator, it doesn't matter. But the root to the denominator should not be there. So that's why, to get rid of this square root from the denominator, we have to rationalize it. So multiply the same number but opposite in sign. So if it is minus, here it should be plus. If suppose it here it is plus, then it should be minus. Multiply and divide. So that's, we simplify the expression to get rid of the square root. All right, now other common type of questions or the rule what we need to know about here is, let's take an example here, or let me mention it as a rule. If I'm writing something like a cube and the fourth root, a cube, fourth root of a cube. So this fourth root of a cube can also be represented as, we know that whatever is there, a to the power 3, whatever the root we are talking about, it should always go with 1 by 4, whatever we are talking. But here in our case, the inside term is gonna be a cube, so that is a cube to the power 1 by 4. Now I can use the exponential rule, so that is a to the power m times n. So this can also be written as a to the power 3 times 1 by 4, this is as good as a to the power 3 by 4. So fourth root of a cube can be written as a to the power 3 by 4. So remember, whatever I'm writing at the numerator of this fractional part, this is the square cube of that, and whatever I'm writing the denominator, that's basically the root value, right? So this is the fourth root, that's why we got it as 1 by 4, or that is the 4 as the denominator, right? So these are the varieties of rules what you need to know for appearing the competitive exams question. So let's see some questions relating with this concepts what we discussed. Let's try to solve some examples. All right, okay. Here they are saying 4 plus 4 root 2 square is equivalent to a plus b root 2, where a and b are integers. What is the value of a plus b? Now we have to solve for a and b here and then add them. So when they are saying this expression is equal to this, when you simplify here, the constant number and the constant number along with the root are basically a and b. So we have to predict the value of a and b by simplifying this expression. So how do we simplify this? This is in the form of a plus b whole square. This is how we write a square plus 2ab plus b square. At the place of a we have 4, at the place of b we have 4 root 2. All right, so that's we can write it as first term is gonna be 4 square plus 2 times 4, that is the value of a, times 4 root 2, that is the value of b, plus 4 root 2 square, that is b square. So that's what equivalent to now 4 square is gonna be 16 plus 2 times 4 is gonna be 8, 8 times 4 it's gonna be 32. This can written as 32 root 2 itself, plus 4 square, because when I'm saying this is the power, this power should be given to the individual. So as we say a times b to the power m, this can be written as a to the power m times b to the power m. The same way we can distribute the power to the individual term. This will be written as 4 square times, this will be written as 4 square times root 2 square. So this becomes 16 plus 32 root 2 plus 4 square is going to be 16 and root 2 square is going to be just 2, right? 16 times 2 it's gonna 16 times 2 it's gonna be again 32. So just add them up, 16 plus 32 it's gonna be 48 plus 32 root 2. So what it is, if you equate this 48 plus 32 root 2, that's we have translated this expression into the general form which I have represented in terms of a plus b root 2. So from this one you can say the value of a here is going to be 48 and the value of b here it's going to be 32, right? So this is you are just comparing. Now question is, what is the value of a plus b? A plus b is 48 plus 32, that's equivalent to 80. So 80 is the value of a plus b in this expression, right? Sometime you may also get a question here based on the square root, saying that let's simplify this. Square root of 16 times 20 plus square root of 8 times 32 is equivalent to which of the following, right? So that's the question. Now when you are trying to solve this, you can solve, there are like many ways to solve math problems, but you have to choose the convenient one which can be solved faster, right? As we are doing the competitive exams and the time is really important here, so you have to look at to the questions and you have to try to find which is the convenient and the fastest way to. So here I can translate all the numbers in a one variable, and so that I can take some of the terms which can be common, whichever the can possible, then the remaining I can leave it as it is. All right, so now how do I simplify this? A square root of 16 times 20, this can be, let me write it in the further way, square root of 16 times 20 plus this 8 times this 32 can be written in terms of, again I can write as 32 can be written as 16 times 2, right? I can modify it. So 32 can be written as 16 times 2. Now look at what is the term common from this, what is the term common here from this one and this one? square root is as it is, the 16 is common, so that is a 16 is the common out, then we left here with the 20 plus 8 times 2, the 16 is left here out. All right, so this is how 8 times, I took this 16 as a common out, 8 times 2 is left, that is 16, and here we took 16 as common out, a 20 is left in a bracket. So now 16, in the bracket what we left here is 20 plus 16, it's gonna be 36. Again, 16 is a perfect square number and 36 also a perfect square number. This can be written as 16 can be written as 4 square and 36 can be written as 6 square. So that is this is a square root and the square will they just cancel out, then this is equal to 4 times square root and the square again they will get cancelled out, it's gonna be just 6. 4 times 6, what we gonna get the value here, just a second, times 6, that is gonna be 4 times 6 is gonna be 24. So your answer here is B, 24 is the right answer to this question. This is how you simplify, by taking the sum of the term as a common out and simplifying the other which are left in. All right. Okay, let's take another example here. These type of questions are commonly asked in SAT and the ACT exams. They are commonly asked, but of course in the other exams also they do, but they are like very common in SAT and ACT. So how do we solve that? Question says, which of the following is equal to a to the power 2 by 3? This is we are expressing, this is they have given in terms of an exponent, and the answer they are expecting in terms of what we say a root, isn't it? So as we already said that a to the power 2 by 3, this can be written as a to the power 2 to its power 3, isn't it? So a to the power 2 and to its power 3 we can write it as, so it's like whatever the denominator that goes with the root and whatever the numerator it stays as it is with the number, that is the square, cube, power 4, something like that. This expression can be further written as a square as it is 1/3, it's basically cube root of a number. So that is cube root of a square will be the answer. So which one is the option here? Cube root of a square is option D. All right. So there may also be a question relating with that. Let me consider another example here which are of same type. If there is a question a to the power, let's take negative 3 by 5, a to the power negative 3 by 5. So as it's a negative number, only we know that a to the power negative n or any number 8 base to the power negative number, this will be written as a reciprocate a to the power 3 by 5. Now I can apply the same approach what we did. So that's only thing is we have to reciprocate it because of negative sign. So that's I can write as 1 over a cube is, as this can be written as fifth root of a cube. So if the question is relating with this will be the option available to choose from that. All right guys, that's it for today's. Let's in the next session I'll be discussing the more and the new concepts relating with the algebra. Thank you so much for watching. Please like, share and subscribe to my channel for the more and the updated videos. All right guys, thank you so much.